Hello friends, welcome to Poultry Conclave, a poultry pathology and nutrition YouTube channel. Ascites in broiler birds is becoming a major issue of concern nowadays. New strains of broiler like COP 430Y, improved Hubbard, Ross and others have the potential to achieve 2 kg body weight in 32 days. To support such enormous growth, high nutrient dense feed is required, which is likely to be metabolized at rapid rate. Higher metabolic rate poses number of problems in broiler, which include skeletal problems, cardiovascular abnormalities, sudden death syndrome, and especially pulmonary hypertension syndrome, which is also known as ascites. Ascites is journal term which refer to the accumulation of the plasma fluid in the abdominal cavity. There are number of etiologies, or we can say reasons, which may cause ascites in broiler bird and sometime in layer bird. These causes either may be infectious or may be non-infectious. Infectious causes of ascites usually do not cause much mortality and only seen in sporadic cases. Economic losses which are associated with the ascites are mainly happen due to the non-infectious causes. In this category, pulmonary hypertension syndrome is the main reason behind the ascites, which is usually seen in the cold weather conditions and responsible for more than 80% of the total mortality happen due to the ascites. Cross-sectional published studies estimates that PHS, pulmonary hypertension syndromes, accounts for 25% of overall mortality in the broiler industry. In simple language, we can say that disturbances in the working of the heart, that is cardiovascular abnormalities, and unusual blood pressure rise is responsible for such high mortality in broilers. And in this video, we will call PHS, pulmonary hypertension syndrome, as ascites. As we know that the main function of the heart is to pump oxygenated blood in the body and non-oxygenated blood into the lungs for its oxygenation. So heart works in a double circuit system, which is being shown in this diagram or in this animation, which means that oxygenated blood that comes from the lungs, which is shown in the red arrow, will be pumped into the body by heart, and after taking oxygen from the blood, body again send this non-oxygenated blood, which is shown in the blue arrow, to the lungs for oxygenation via the heart. Here it is essential to understand one question, that why more oxygen is required in cold weather condition that increases workload of the heart. Body temperature of the bird is 5 degree more than human. That is why higher amount of feed and metabolic rate is required to maintain bird's body temperature. High metabolic rate means high amount of oxygen is required to burn extra feed consumed by the birds. Further, in colder condition, body loses its heat more rapidly into the environment and bird consumes more feed to compensate that lost heat. As feed intake rises, body oxygen needs increases. But broiler lungs have the limited capacity to supply the oxygen to the blood, because the lungs of the birds is stick into the thoracic cavity and they are not free floating like us. So the expansion of lungs is very difficult. So its capacity to have the air is very limited. So this results in the hypoxemia, which means the less oxygen is available in the blood, or oxygen deficiency in the blood occurs. Hypoxemia results in increased cardiac output. Heart has to do more work. The workload of the heart increases. Polycythemia, which means the number of red blood cell increases, and increased hemoglobin to carry more oxygen along with the increased hematocrit. These changes in the blood produce an increased blood viscosity. The viscosity of blood increases, due to which blood pressure inside lungs starts increases and blood pools inside the lungs. The blood starts collecting in the lungs. As the blood pressure in the pulmonary vessels rises, water from blood pushed out from the blood vessels into the outer space, as shown here by the green. Workload of the heart increases in case of ascites when blood pauses inside lungs for its more oxygenation. In short, we can understand it like this. So bird starts feeling deficiency of oxygen, and physiology of birds changes. As a compensatory mechanism, bird changes many of its body parameter, like it increases number of red blood cells to increase oxygen carrying capacity of the blood, but this increases blood viscosity. In short, these changes are seen as hypoxemia, deficiency of oxygen in the blood. Blood pools inside the lungs to collect more oxygen. Right part of the heart enlarges to push more blood into the lungs, but lungs are already get saturated with the blood. Another thing, lungs are unable to remove excess carbon dioxide from the blood, due to which respiratory acidosis builds up, which ultimately converted into the metabolic acidosis. Blood pressure inside lungs rises, which is called as pulmonary hypertension syndrome. The plasma from blood oozes out into the open space. When the heart unable to pump blood into the lungs, blood pools in the vena cava and pressure builds up inside the liver. Liver gets enlarged and plasma fluids comes into the abdominal cavity. In such events, heart gets under tremendous workload, but to cope up with these changes, heart increases its size. But after certain limit, heart failure occurs, and that thing is responsible for the rapid death in case of ascites. No doubt that pathogenesis of ascites is complex and difficult to understand. That is why control of ascites in outbreaks could become difficult. Control of ascites induced mortality is necessary sometimes to reduce economic losses. To reduce mortality, we have to work simultaneously on many things which are got disarranged, like we have to reduce high blood pressure, correction of cardiac arrhythmia, neutralize metabolic acidosis, improves kidney filtration rates, and most importantly to reduce the oxidative stress generated due to the unavailability of the oxygen. Free radical control through transmembrane antioxidants is a part of therapeutic management of ascites. Although it is a complex subject and need more studies of basic physiology to understand it completely, but still I hope you may understand it sufficiently that this problem is related to the high growth rate of modern broilers, along with increased oxygen demand in cold weather conditions and reduce oxygen carrying capacity of the blood. So thank you for watching this video. Please like and subscribe Poultry Conclave YouTube channel.